Well, hello Internet, and welcome to my new Java video tutorial. In this one tutorial, you're basically going to get a 1,000-page book on Java crammed into one video. Underneath the video, you will find a table of contents. You can click on anything and jump throughout the video to all the different topics covered. And in the description under the video, you will find all of the code as well as a transcript of this entire video. And I have a lot to do, so let's get into it. Okay, so I decided to use the Eclipse IDE because it's free and Java works the same on everything. So use anything you would like. And what we're going to do here first is come in and say that I want to create a new Java project. And I'm just going to call this Java Tut, and that's fine. And you can see I'm using Java 11, or I think you can see it. That's what that says right there. And I'm going to come down here and click on Next. This is all perfectly fine, and I'm going to click on Finish. Under the module name, I'm just going to call this Java Tut and go and click on Create, and everything is all set up here. So I'm just going to close that guy, and I'm going to come over here and create a class. And a class is basically, I'm going to get in much more detail. Basically, a class is just going to be a model of a real-world system or object. But like I said, I'll get more into that later. So I'm going to go and right-click on that in the source folder, and I'm going to say I want to create a new class. Come over here, and the package is normally going to be something like a website or something unique so that you don't have any conflicts with anything. So I'm just going to call this com new think tank because that's my website. I'm going to come down here and say yes, I want to create a main function inside of this class, and then I'm going to go and say that I want the name of this class to be hello world, and I'm going to click on finish, and that's going to be created for me. This right here is a comment. 2 forward slashes gives you a comment, and if you would want to do a multi-line comment, you just do a forward slash and a star, and then start typing your comments inside of there. You can see up here is the package that I set up, and basically the class where all of your code will reside is going to be between this curly brace and this closing curly brace, and execution of your program is going to start inside of the main function by default. Public just means that anyone or any code that has access to your class, and this is your class name, is going to be able to run this. Static means, and there'll be more on this later in the tutorial, it basically means that it is a function that belongs to the class. Like I said before, we create objects and such, and some functions are going to be specific to the objects we create, and some will just be based off of the class. If it says static, it'll be class. But like I said, more on that later. Don't worry about it if it doesn't make any sense. Void means that this function does not return anything after it executes. And string basically means that if we run our program on the command line or terminal, that it can receive a string array, just a whole bunch of different words or whatever you would want to pass into it, and they would be stored inside of this function called args. Okay, a lot of complicated stuff here that I will explain much later in much more detail. Now I'm going to be using a whole bunch of borrowed libraries of functions, and if you would like to import some of them, so one of the ones I'm going to use is Java util, and if I want to import all of them, I put a star at the end of it, and this is going to be used for array functions, ArrayLists, Iterators, and a whole bunch of other different things. I'm also going to be using something called IntStream that is going to be used to generate ranges. So if I want to go and get those functions that have been pre-made for me, I can do that. So I can go util stream and int stream. And for now, that's all I'm going to bring in there. Now down inside of my class, I'm going to want to be able to receive input from a user. And so I'm going to mark this as static. And this is a scanner object. So it's going to be allowed to input information from the keyboard. Say new scanner. And if I want to get information from the keyboard, the Java way of referring to that is system_in. If you would like to make a constant variable that's value is never going to change, you're going to start that off with the word final, and then double is what this guy is going to be, and I'm just going to call this short pi is equal to 3.14159. Okay, so once you set that value, it cannot be changed. and that is called a constant. Okay, so now what we're going to do is fulfill the whole hello world thing that we want to do here. And if you want to output information into your console, you're going to type in system out followed by Println. And what Println means is that it wants to print out everything that is between the double quotes and then add a new line at the end of it. And there you go. That's all you really need. You don't need all this stuff up here to have a Java program, but that's what you need to do hello world. And then if you want to use Eclipse, what you're going to want to do is click over here. There's a little downward arrow, and you're going to go to Run as Java application, and you're going to see hello world comes up over there. From then onwards, you can just hit the little play button and it'll work. So there you go. Now you know how to do hello world. Now what I want to do is talk about variables. Now a variable must start with a letter and then have letters, numbers, underscores, or dollar signs inside of them. And to create a variable, what I want to do here is create an integer, which means that it's a number that does not have any decimal places. And so let's create one. And all your statements have to be ended with semicolons. These guys right there. You're also going to be able to create multiple different variables at once just by going int and then v2 and v3 or whatever you'd like. So you can have multiple different variables on the same line. And that's just the basics of variables. And now what I want to do is talk about data types. Now Java requires that every variable have a defined data type. And basically what data type means is how much space we are setting aside in memory to store the values we want to store. Okay, so you can see all the primitives here. There's byte, short, character, boolean, int, float, double, and long. And like I said, they are all going to be able to store a minimum value as well as a maximum value. And how we go and figure out what the maximum value or the minimum value of a byte, for example, is to just follow up the data type's name in uppercase letters and then followed by max value or min value. And then if we run that, you're going to see all of the minimums and maximums for all of those different data types on the right side of your screen. To get more into the specifics, a Boolean is either going to have a value of true or false, and you can't use 0 or anything else like you would use in other languages. And so let's come in and create one, and we'll say happy, and we'll just mark that as true. Characters are only going to be able to store single characters, and whenever you define them, you are going to have to surround them with single quotes, just as I did right there. You're also, however, going to be able to store inside of character types things like new lines and tabs and backspaces and form feeds and returns, as well as double quotes, as long as you go and do a backslash, or single quotes or backslashes in that situation. Floating point numbers are going to be able to store decimals, and they are going to have a precision up to 6 decimals, as you're going to see. So let's come in and do something like fnum is equal to, and just make sure if you want it to actually be a float that you end it with an uppercase F. Then what we'd be able to do is to output some information onto our screen, and here I'm going to show you the precision of a float. So then I'm going to say float like this, and then if you want to concatenate or join different types of data, you just put a plus sign inside of there and it'll form those together. You can also continue to the next line without any problem. And then I can do something like fnum plus fnum2, and you're going to see that this messes up whenever we run it, and see it has 6 points of precision. As you can see, it messes up on the 7th place. If you decide that you need more precision than a float provides to you, you can come in and use a double instead. So we could do something like double num, and we could go and get these same values. And basically a double is going to have a precision up to 15 decimal places, and you don't put an F on the end of it, of course. And if we go and put that inside of there and then run it, you will see that a double is much more precise than a float. And you can come in here and type double, of course. All right. You're also going to be able to use scientific notation whenever you're creating your values. So let's go double and 1000, for example, 1e plus 3, and then we can come in and print that value out, and you can see that it works. You're also going to be able to use longs, which are very large numbers, as you saw previously, the maximum size for those. And sometimes when you're working with very large values, it helps to separate things. So you can use underscores, for example, like this as well. Okay, so there is a rundown of the different data types that are available, and much more will be covered with them as the tutorial continues. And now I want to talk about casting. Now, by casting, all that I am referring to is converting from one data type to another. And by default, you can always convert from smaller types to larger types. So let's say we create an integer here. I'm going to call this small int is equal to 10. I can then go and get a long and go small long is equal to small int, like that. And everything works without any issues. However, if you are going to be converting from integers and doubles and from large to small, you're going to have to do that in a different way. So let's go and create a double, and I'll call this C double is equal to 1.234. Now, if I would want to convert this into an integer, I can, and let's just call this C int is equal to, all I need to do is put what I want to convert it into inside of parentheses like that, and there are no issues. It will automatically convert it. Of course, it will lose all of the decimal information, however. And if I go and output that, you will see that that is indeed true, and you just get a value of 1. If you are going to be creating a long, go big long like this, is equal to, and you can go and put in whatever value you would like inside of here, and let's end that with an L to represent that's a long. You can then come in and go int and bint equal to, and know that you're probably going to get some weird results, but let's go and do it anyway just to show you what happens. So let's convert a long into an integer, and you can see that you do get a really weird value. Alrighty. If you would want to be working with strings, we can go and create a string, just a series of characters. That's all a string is. And you'd be able to convert to a string by using a wrapper class. So let's go favorite number is equal to double and toString. So the toString works with any of the other data types to convert them into strings. And then you can throw in whatever you would like inside of here, and it's automatically going to work and perform that conversion. And also you would be able to convert strings into all of the different data types by just typing in byte, for example, and then following that up with parse byte, boolean, parse boolean, and the same exact format as I'll show you right here. So let's go comment that out, and let's create an integer, and I'll go string int is equal to, and in this situation we will go integer and parse int, and then throw our string inside of it, and it's going to convert it from the string format into the format that we want, which is an integer. And we could do this, but it's not really going to matter either way. Okay, so there you go. And that is how you cast from one data type into another multiple different data types. And now I want to talk about some math functions. Now, of course, you have all the basic types. You can add, you can subtract, multiply, divide. This is modulus, which gives you the remainder of a division. And if we go and run that, you can see exactly how the output works. Other things to be aware of is that math done on integers defaults to the integer output, and doubles return doubles. So if we would do something like this, and 5 divided by 4 is equal to, and then plus, and we'll throw in a double. So we'll go 5.0 divided by 4.0, and close that off. And run it, you're going to see that we get double values here because we performed this operation using doubles. There's different shortcuts in regards to performing operations. So for example, if we have inc me followed by plus plus, that is going to be equivalent to if we went inc me equal to inc me plus 1, as I'll show you here in a second. So let's go and create inc me and give it a value of 0 to start off. Then what we'd be able to do is go and I'm going to show you something that might throw you off, because sometimes it throws people off. If we would come in here and do this and add this in and go inc me plus plus, I'm going to actually show you the results, and then afterwards I'm going to explain what happened. So here we'll go inc me, get the plus plus off of there, and instead put it in the front. Now, what do you think it's going to provide you for output? Well, if we run it, you're going to see that 0 comes out. And you think, oh, that doesn't make sense. Well, what actually happens whenever you put the addition on the right side, it goes and outputs whatever the current value of inc me is, which is 0. Then it increments. Down here, in contrast, when you put the plus plus in front, it goes and adds. Now the value of inc me is 1, so it becomes 2, and then it outputs. So just something to refer to, or something to be aware of in regards to that. And the other shortcut that is available to you is if you wanted to increment the value of inc me by 10, you could just go plus equal to 10, and that would increment that value. And of course, that would be exactly the same as if you would come in and go inc me is equal to inc me plus 10. All right, so just a couple little shortcuts, and now I'm going to show you a ton of math functions. These guys are all going to be built in, so you can get absolute value, ceiling, floor, round, and so forth. Let's go and run it so you can actually see what's going on. And there is, look at all those different guys. So absolute value, ceiling, floor, round, max, min, exponents, and all of the other different mathematical calculations you can perform using Java. And there's going to be all kinds of other cool things we can do with math, as you'll see in a bit. And we're also going to be able to come in here and create random numbers. So let's go and create or define our minimum value that we want to work with, or which is going to be equal to 5. So let's say I want to generate a random number that goes from 5 up to, say, 20. This is exactly how I do that. So I can go int and random number is equal to, and I'm going to go minimum number plus, and then I want this to remain as an integer, so I'm going to say int, and that's going to convert it into an integer, and then I'll say math, and the random function is going to help us out here with generating this. And let's say I want to go to the next line, I can, and then I'm going to follow that up with the max number minus the minimum number plus 1. And now we can come in here and see it. So I'm going to say rand plus and random number to see our output. And if we run it, you're going to see you get 11. And each time we run it, we're going to get completely different random values, just as we were hoping for. So that was a whole bunch of information about math. Now I want to talk about strings. Now, strings are going to be objects, or what are referred to as reference types. And they're going to have a whole bunch of built-in methods, and you're going to see a whole bunch of them here in a second. So let's go and create a string, and let's just have this be Derek. Now, like I said before, you're going to be able to combine strings with the plus sign, as you already have done. So we'll do something like whole name is equal to, and I can go and throw the variable version of it inside of there if I'd like, and then go and put the rest of my name. And there we go. We're able to combine those two different strings. You can also come in and change the value of your variables, if I didn't mention that before. And let's say we want to join a string to another string. We can do that is my name, and there we go. So you can use that shortcut for things other than just doing math. Now, our conversion is going to be automatic whenever you are using primitives of any type. So we'll say doctor's dog is equal to, and K, and then go 9 like that. And that's automatically going to work. And each string that you work with is going to have each of the characters inside of it, or they're going to have indexes or addresses or whatever you want to refer to them. And how you refer to the first character is index 0, and then 1, 2, 3, 4, and so on. And if you want to actually get the character that is at a specific position, like the 0 position, you just type in character at, and then run it, and you're going to see that D comes back. You're also going to be able to search through strings to see if they contain other different strings. So for example, I can come in and I can go w name dot and see if it contains the other string I'm searching for here, which is going to be Derek. And it'll come back as true if it does find a match for that string. You're then going to be able to get the index of that specific match as well, just by going in and referring to the string once again. And then you will say index of, and then type in what you're specifically searching for. And then you can see it came back. You're going to be able to get the number of characters that you have inside of each of your strings just by typing in length followed by your parentheses. Those are very important. And one thing that's important is whenever you are trying to compare strings, as you're going to see later, equals, that represents equals, is often used whenever you're comparing numbers and such. You should never, however, do that with strings, but you should instead use equals. So for example, let's go in and let's do something like dog equals cat, and then we'll get our result from that. So let's go and output this. And how you should do string comparisons is to, for example, type in dog and then follow that up with equals, and then inside of here what you are trying to compare it to, which in this situation would be cat. And if you do that, you're going to see it comes back as false. There's other ways that you can compare your different strings. And one thing that I want to make sure I cover is if you want to compare two different strings and you want to ignore case, you would instead just go equals like this. It's not going to matter in this situation, but we can go ignore case, and that will allow us to compare different strings and ignore the case. There's other ways to compare your characters as well. Let's say that I would come in here and go WName and compare to, and then follow that up with something like ABC. I could do that. And basically the way this works is if this gives us a result of 0, that means that the strings are the same. If it gives us a value of -1, that means that the string comes before, and then anything above that is going to mean that the string comes after, which is how we get 3 as a value like that. Now we're also going to be able to come in and replace any different matches that we have. So let's come in and we'll go WName and replace, and let's change this. What we're searching for and what we want to replace is Derek in this situation, and we want to change that to Bob instead. That's how easy it is to change those strings. We're also going to be able to get a string using the indexes that I've been referring to. And how you do that, let's say we come in and go WName and substring and say we want to start at the 0 index through the 5th. You can do so and run it, and you can see it just grabs my name out of there. We're also going to be able to turn strings into arrays, which we are going to cover more later on. And what I'm going to do here is I'm actually going to use what's called an enhanced for loop, which I will cover more later on. Just allows you to iterate or slowly go character by character through a string, for example. So I'm going to go string x, and I'll cover this in more detail later. If we want to convert a string into an array, we would just go WName and then follow that up with split, and then we would go and put a space inside of here, and that's basically saying everywhere there is a space inside of the string, we want to convert the words before and after the space into things that go into the array. An array is just a whole bunch of little boxes that you store stuff in. Okay, so what we're going to be able to do with this enhanced for loop is a neat little trick where we're going to be able to run and output all of that information, and you can see that it did that. Derek Banis is my name. It went and took each of those individual words and stuck them into their own separate boxes inside of an array. Other things that we can do that I'm not going to cover is there's also going to be a trim function that's going to delete white space at the beginning and end of the string. You can do uppercase like this to convert every single character in the string to uppercase, and you could also come in and do the same thing with lowercase. Alrighty, so there's a whole bunch of things on strings, and a whole bunch more is coming later. And next I want to talk about string builders and buffers. Now, if you are going to be making many string changes, you may prefer to use a string builder for reasons. Every single time you create a string, it creates a new place in memory, and it can cause a lot of havoc. So making a whole bunch of changes, use a string builder instead of a regular old string. And the only difference between a string builder and a string buffer is a string buffer is used whenever you're using threads. I'll cover threads later on in the tutorial. So let's go and create a string builder. And how you do it is just go string builder like that and equal to new string builder. And then you can come in and do something like I'm a string builder. And of course, you're going to be able to put this on a separate line if you'd like. So let's just come down here and do that so it looks a little bit nicer. All right, so there you go. You just created a string builder. You're going to be able to come in and get the number of characters that you have inside of it just by coming in and doing length, just like we did whenever we were working with strings. You're going to be able to get the size that is set aside for your string builder because it gives you a certain size actually larger than what you requested whenever you created it. And how you get that is you just come in and do capacity. I'll run this in a second. You're also going to be able to append a primitive or a string to your string builder just by using append. And let's just do something like yay, and there it is. You're going to be able to insert at a specific index if you'd like. So let's go SB and insert, and we'll say that we want to insert at the 6th index the word big, and you could do that. Let's run it just to see what that is. And there it is. I'm a big string builder. Yay. See how that works? You could go and replace at a specific index. So let's do replace, and we'll say from 6 through 9, and what we want to put inside of there instead is wig. That'll work. You're going to be able to extract substrings out of this. So let's go and do something like SB and substring. And we'll go 6 through 10 and make sure that you keep the name that's exactly the same. Otherwise, it obviously will not work. You can also come in and delete characters at an index. So we can do something like delete and 6 through 10, and then close that off, and we can run it and see all our different results. Just like with strings with the exact same function name, you're going to be able to come in and get a character at a specific index. So we could go character at, and we could do 4. And then finally, we can get an index for our string that we type in. So we could go SB and index of, and then throw in a specific string, and it'll give us that result as well. And if we run it, you can see that all that works. Okay, so there's a rundown of string builders and string buffers. Like I said, just use a string buffer instead. Obviously, it's like this, FF, if you're using string or if you're using threads. And now I want to talk about arrays. All right, so basically an array is just boxes in memory that allow you to assign a name to multiple values instead of just one value. So let's go and let's create an integer array, and that's exactly how you do it. And let's say that we would like to set aside 10 spaces for our numbers. So we'll just go int and then say 10, and that's what it does. It sets aside 10 boxes to store 10 integer values. We can go and assign them using indexes, just like this. So let's say we want to put 1 in the very first box in the array. That's how that's done. We can also come in and fill the array with a value. So we can say arrays and fill, and you just put in what the array name is and what value you would like to fill every single little spot with, and that's going to put a 2 in all those spots. Also going to be able to get values by referring to indexes. So let's go and get that. You're going to be able to come in and get your array size just by following that up with the word length. As you can see, we're reusing a lot of things. You're going to be able to create and add values at the same time. So let's go and go string, and a2 is equal to, and we will throw in, we can throw strings inside of here. So we'll say 1 and 2 like that. Just make sure, of course, if you call this a string array, you have to put strings in it. If you call it an integer array, you can't put doubles in it, okay? Just a rule. You're going to be able to generate an array. So let's go and go int, and let's call this 1, 2, 10, and I'm going to use the integer stream, which I'm going to cover in much more detail later. So you just go range closed, and I want to generate values from 1 to 10 and inside of this array, and then I need to convert them into arrays. So there we are from the integer stream. You're going to be able to use that enhanced for loop that I talked about before, and how this works is it's going to cycle through every single value in the array, temporarily storing them into this variable that we call x. Then you're going to put in whatever the name of your array is, 1 to 10. And since this is a single line statement that we want to work with here, you can put that all on one line. You don't need to surround it with curly brackets, and the world will be fine with that. And there you can see I cycled through all of them and printed them all out on our screen. You're also going to be able to find values you're going to type in arrays and binary search, and you're going to type in whatever the array is that you want to search through. And I'm specifically searching for a value of 9 inside of that array, and it's going to tell me if indeed that is found or not, or it's going to tell me what index it found it in that situation, which is 8. You're also going to be able to create what are called multi-dimensional arrays. So this is just arrays inside of arrays, and to create one, you just come in here and put these 2 brackets if you want to do just 2 of those. So we'll go equal to new, and then inside of it you have to say how many different spaces to set up inside of those guys. So let's just go like that, and there you go. You just created a multi-dimensional array. You're also going to be able to create and initialize at the same time. And one thing that's kind of confusing is sometimes people wonder exactly what this looks like, and what the multi-dimensional array looks like. Basically what we're saying here is how many down or how many rows we want to set aside, like matrices with mathematics, and this number tells me how many across. So let's go and let's create and initialize at the same time. I'm going to go string, and I'm going to say that I want to create a multi-dimensional array. I'm going to call it A4, and I'm going to initialize it at the same time. And how you do that is just multiple curly brackets. So we'll go 0, 0, and 1 and 0, and then we're going to close one curly bracket and then create another one. So let's go like this, get that to line up a little bit better, and then we can say 0, 1 and 1, 1. 1, 1, like that. And then we close off both of the curly brackets at the same time. So there you go. You went and created and initialized it at the same time. Now I got a stray curly bracket here, and we come in here and we'll actually print these values. So let's say that we wanted to print using an index for our A4. Let's say we wanted to get the first row as well as, well, this is actually the second, because remember it starts at 0. So the second row, second column value is what we're looking for, and we can run it, and you can see that that indeed is 11, which is this guy right here. Let's go and create a 3-dimensional. So let's go string and A5, and if we want to have 3 dimensions, you just go and do exactly that. And then if we want to go and put different values inside of there, 1, 2, 3, if you're working with 3-dimensional, you're going to have 3 of those curly brackets. And I just went ahead and created that. And if we want to go and output a specific index on the screen, we can just go A5, and we'll do something like 2 and 3 and 0. And whenever we're working with 3-dimensional arrays, remember I said before, the first value that we have here is basically going to be our rows, meaning this guy is the rows and the columns, and this would be like pages. So if you think of this as a 3-dimensional object. And if we run it, you'll see we got 320 to show up there. And I'll be doing all kinds of other cooler things with arrays as the tutorial continues. Let's go and I'll show you how to copy one array into another array. So we'll go like this, and we will initialize. Let's go A6 like that is equal to, and we'll do something like 1, 2, and 3. And then we'll go and create another array. So this is going to be A7 is equal to, and if you want to copy one array into another array, you just go arrays and copy of, and the array that you want to copy from, and then how many values you want to copy specifically. You're going to also be able to come in and compare arrays. So we'll go arrays, and you're going to use equals once again and compare A6 with A7. And also you're going to be able to sort arrays. So let's go and get A8, and let's initialize an array that does not go in order, so we can see that we can get the computer to do the heavy work for us. And how you do that is you call the sort function by passing it the array that you want to sort. And then we can come in and go and convert an array into a string that we can output just by going arrays to string and pass in A8. And if we run it, you can see that all works. All right, so there is a whole bunch of things on arrays, more coming up later. Now I want to talk about array lists. Okay, so people use array lists because they resize and provide for easy insertion and deletion versus a regular array. And how you would create one is you go array list and string. This is if you want a string array list, and you can obviously put anything you want inside inside of them. And let's say that I want to have 20 spaces set aside whenever I very first start them off. This is how you would do that. And then just put the 20 there at the end to define how big you want it to be. Now, if you want to go and add values to an array list, you just go add, and you can put something like Sue. You can also generate an array list, and here I'll show you a way to do it. So we can go array list, and this time I want to generate an integer array list. Note the uppercase I that you have there. And then we can come in and go array list, and then I will generate one. So I'll go arrays and follow that up with as list. And then I can just throw whatever values inside of there that I would like. And then I want to, of course, make sure that I close this off with a semicolon at the end. So there is how we generate that. And we can come in and use our enhanced for loop to go and print out all of the different values. And like I said previously, everything will temporarily be stored inside of X as we cycle through it. And because it's just one line, we can just come in here and put this all on one line. And then we can end that with a semicolon and output that information. And you can see there it is on the screen. And you can also note I didn't put print line, and that's the reason why everything showed up on one line instead of two. We can, of course, come in and get different values out of here as well. This time I will use Println. And if you want to get an individual value based off of the index for it, let's say we want to get the second value out of there, you can of course do that. You can add a value at a specific index just by coming in and saying set, and let's go 1, and let's throw a 5 inside of it. You're also going to be able to come in and remove values by typing in remove, and let's go and say we want to delete, the 3 index. You would also be able to clear the entire array by going AL2 followed with clear. That would delete everything. And then let's talk about iterators. Basically, an iterator is going to allow you to cycle through collections like array lists and other collections that we have seen and will see. And to create one, you just go iterator, and I'm just going to call this IT is equal to AL2 and iterator. And there you go. Now you have an iterator. And to use it to cycle, I'm going to cover loops here in a second. Of course, you can always jump around within the playlist. And how you call for each of the individual values in the array list is has next. And then we can come in and output each of those individual values. So we can just go it and next, and as long as there is a value to output, this loop will continue looping forever. And then it'll output all those different values. Okay, so brief overview of some things you can do with array lists. I actually prefer linked lists, and that's what I'm going to cover next. Now, linked lists are basically used or best used whenever you find you have to make many changes in the middle of your list. I have an entire tutorial on how they're created, but basically the way they work is that each item or link in the list has only a reference to the value before and the value after it. And how you create one is you come in and go linked list, and let's say you want to work with integers, and let's just create one here. Equal to new, and then linked list again, and then of course integer, and then you can just say whatever you want inside of it, just end it at the end of there. And then if you want to come in and add a value, you can just do add and throw one value inside of there. You can also come in and put multiple different statements as long as you have semicolons on them, all in one list. I don't know if I said that before or not, so let's just go and throw a couple values inside of there. You would also be able to add a whole list of items just by going add all and then using arrays as list and then throw a whole bunch of different values inside of there. You would be able to add to the front by going add first, and let's just throw 0 inside of there. You would also be able to use add last, but I'm not going to do that. You can do it on your own. You can check if a value is inside of a list by just listing that and then following it up with contains and whatever value you are looking for. You can get the index for a match just by typing in index of and the for your or whatever the value is. You can replace values by saying set and 0 and 2, for example. And I'll output all of this all at one time. You can get values just by going like this and then following that up with get. And let's say we want to go and get what's in the 0 index. And just run that just so you can see what that looks like. And there you go. You can also call get first and get last to get the first and last item. You can remove items just by using remove and then follow that up with the 1 there. And you'd also be able to do clear, which is going to remove all values. You'd also be able to come in and get the number of items that you have inside of it just by calling size. And you would be able to convert it into an array. Let's just go and create an object array, which is the most basic form. And we'll go to array. And of course, I can use the enhanced for loop here to output all the different values that are in the linked list. All right, so there you go. Rundown of linked lists. And now I'd like to talk about user input. Well, now I'm going to show you how to use the scanner to get some user input. And let's just go and system out. And we'll do something like enter name. And if you don't want it to give you a new line, get rid of ln, of course. Now what we need to do is worry about what data type we are going to be working with. So what I'm going to do here is I'm going to check if the user actually entered a string. So I'm going to use the scanner object up there, and I'm going to go has next line, which is what you use if you are going to be receiving a string input, and make sure that this is uppercase. And what you would do is instead of line represents strings. If you want to check for any of the other different data types, you type things like short or integer or whatever the different data types are. Then if we come in here and we did get a string, what I can do is say username is going to be equal to, and if I want to get that string that they entered, I go next line, and then I can get it. And of course, just replace the line with things like short and integer to get them to work with the other different data types. And then I can go and do an enhanced hello world. So I can just go like this and then follow that up with a username. And if we run it, it'll say enter name, and I can come in here and say Debbie, and it'll say hello Debbie. All right, so cool stuff. You can also go and use dialog boxes. So let's go and open a dialog box. I'll call this job name is equal to, and then we can go down to the next line. And then what I want to do is go J option pane and show input dialog, and I can put my message inside of here, which is going to be enter name. And then I can go system out and do a hello world thing again, just by going JOP name, and it's giving me a underlined little error here. Inside of Eclipse, you can just put this here and it'll give you the option to import JOption pane. Import JOption pane Java X swing. Just do that. Problem goes away, and we can save it and run it. Enter name, and I'll say Sue. Hello, Sue. And you can see here is the dialog box. And I can go Derek and click on that, and hello Derek shows up. All right, so 2 different ways to use user input. Now I want to talk about conditionals. Now, if you want to perform different operations based off of conditions, you are going to use relational operators, and that is just a fancy name for things you've seen before, which is equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. And then you can use multiple different comparisons using what are called logical operators, and those are going to be things like not, which is going to give you the opposite of whatever you give it. So if you say you go not true, it's going to give you false. Not false gives you equals true. And then you also have and you also have or. So I'm just going to give you a whole bunch of examples that show you exactly how those work. So let's go and create an integer called age, and let's say the age is 12. What I'm going to do now is I'm going to say if the age is greater than or equal to 5, and we also have an age that is less than or equal to 6. Well, in that situation, the curly brackets are very important, as are the parentheses. I am going to output go to kindergarten. See, both of those need to be true, otherwise this will not print. Now, if you would like to have another if statement inside of here, what you can do is say else if, and then you're going to do another condition like this. So you can stack those inside of there. So we can go like this, and in this situation, I'm going to say 7, and I'm going to say 13. And then the message is going to be different, of course. So I'll say middle school, and then we just keep on going. So let's go and get this guy right here, and go to the next line. Else if, and then I can change this to 14, and then I can change this to 18. And then I'm going to have one more, and that is going to be just a simple closing of that curly bracket. And then I will list my default, and that is going to be stay home. So just grab that guy, throw that inside of there, and I'll say stay home. And you'll see how this all ends like that. And if I run it, go to middle school comes back. All right, so I'm going to do a couple more examples here. Show you exactly what the OR operator does. So let's just go like that, is equal to, and then close that off, and then add on what we're doing. So we can just go true, and then OR false, close that guy. And there you can see that that comes back as true as long as one of the values is indeed true. We can also come in and I'll show you what not does. So not true is going to be equal to, and then we can just do not true. And like I said, it's going to provide false, just the opposite of whatever you are doing. More examples. You also have something called the ternary operator, which returns one value if the condition is true, or the second value if it is not. So I can say something like boolean can vote, and can vote will get the first value that I'm going to define here if the age is greater than or equal to 18. And you just follow that up with a question mark, and we're going to give it a value of true if that's true. Otherwise, we will give it a value of false. And of course, you could give it the value of, if this was a integer, you could give it a value of 1 or 0 or whatever you'd like. It doesn't have to be true or false. And we can come in and output that. Right, like that. There's also the switch statement, which is often used when you have a very limited number of options. So let's go and create string lang is equal to and France. This is going to provide different output depending upon the language I define. So I'm going to say switch, throw the thing that we're going to be searching for value-wise, curly brackets, of course, and then we're going to put in our different values. So I could do something like Chile, and if you want to check for more than one, you just end that like that, and then go and put another case on there, and we could do Cuba, and then we could put our condition inside of it, which is basically going to be hola, which I think I pronounced that correctly. All right, and then to end checking anything else, we put break. If we don't put break inside of there, it's going to check the next value inside of it and then ultimately print out what is in default. So you normally are going to want to put a break statement inside of there. And here we could go bonjour and break again, or Japan with konnichiwa. Or if none of those end up being true, we can come in and do default and then output on our screen hello. So there we go. And if we run that, you're going to see that bonjour comes back just as we were expecting. All right, so there's a whole bunch of different ways of handling conditionals. And now I want to talk about looping. Okay, so Java, like most programming languages, is going to have a for loop. And what you do is you assign a starting value, and then you will continue looping as long as this condition is true. And then you have to define how much you want to change the value of I each time through the loop. And you could then come in here and just print that value. And it's going to do basically what you would expect. While loops are going to continue to execute as long as a condition is true. So we can just come in and go WL is equal to 0. And you're going to have to put your value outside of the while loop like that instead of inside with your for loop. And we can go and say that we want to continue cycling through the code between the curly brackets as long as that is true. So let's say we only want to print even numbers. We can say if, and like that, and anytime you do modulus of 2 and it comes back as 0, you know you have an even value because there's no remainder whenever you divide by 2 with an even value. And we can go in and print that value, and don't forget to increment the value after you do that. Change this to uppercase. And then if you want to skip executing code that comes after these curly brackets, you'd go and put continue in there, and it jumps back up here and starts executing from the beginning. So that's what continue does. And then we could throw another condition in here, and we could say something like if WL is ever greater than or equal to 10. In that situation, we want to stop looping altogether. And if you ever want to stop looping altogether, you type in break, and that's the end of that. And then, of course, don't forget to increment the value of WL. And if we run it, you can see only the odd or even values up to 10 are printed out on the screen. So that is the while loop. Now let's talk about the do while loop, which is basically going to definitely execute at least once. So let's do something here a little bit fun. Let's go and put in secret number and say that the value is going to be equal to, you tell me, 0 through 10. How about 7? All right, so then I'm going to put a guess inside of here, which is going to be equal to 0. And then I'm going to go do, and we're going to continue executing as long as the user does not enter in the value that we want them to enter in. So we'll say guess, and we can go and put this on a separate line, or get rid of the new line, I mean. Then we can say if, and check with the scanner to see if they entered an integer or not. And then we'll have guess is equal to sc next int. And then what we do is put the while part at the end of the do while loop. So we'll just come right here and we'll say while secret number is not equal to guess. And then like that. And then we know also that once they get out of this loop that they actually guessed the secret number. So we can put it down there. All right. And the way this operates is we have guess, and we can go 5, and it's going to continue asking for guesses until I have 7, and then you guessed it, prints out. So there's a couple more ways you can loop. Of course, I've already talked about the enhanced for, and I'm going to show you a couple other different ways, but now I want to talk about methods. Now, methods are basically going to allow you to avoid duplicate code and help you organize. And let's go, and you have to create them outside of your main function. So I'm just going to create a whole bunch of them here. So let's create one that is going to receive 2 values and return a sum. Now I'm going to type public inside of here and static int get sum, and then I will list the 2 values along with the data type of the 2 values that this function or method is going to be receiving. And basically, public methods are going to be able to be executed by any program that knows of your class. You could also come in here and mark this as private. If you do that, that means that these functions or methods are only going to be available inside of the body of the class. And if you go and mark it as protected, that means that the methods are going to be available to your class as well as any subclasses that you create. And I'll cover more on subclasses in a little bit. Static, like I said before, means that it belongs to the class and not to any objects of the class. Again, more on object-oriented programming later. Int means it's going to return an integer. So let's finish this up by just going return and then adding these 2 values together and returning them. Now down inside of main, we can actually call our function. So let's go and say something like 5 plus 4 is equal to, and then just call our function to get that sum by passing in 5 and 4 and run it, and you can see we get our answer. Okay, so simple method will get more complicated. Now, one thing that is very important to understand is that all data that is going to be passed to a method is going to be passed by value. So changes in the method have no effect outside of your method. So let's go and create an integer. Call this cnum for change number. Let's give it a value of 0. Then I'm going to call a function that I'm going to create here in a second called change me. And then I'm going to output the change here just to demonstrate this. So change number's value is going to be equal to change number. So we're going to be passing change number into change me, which we're going to create right now. So once again, this is going to be public and static. It's not going to return a value, so I'm going to put void inside of there. And change me, it's going to receive the change number variable, and it is going to change the value, or try to change the value, that is. But as you see, whenever we run it, it still has a value of 0. So what happened here is 0 was passed in. However, a new variable was created that is only inside of the change me method. Once the change me method ends right here, this variable no longer exists. So I passed a value of 0, we changed the value to 10, but it has no effect on this. Even though the names are the same, they are completely different variables. Now let's say you would like to be able to provide a variable number of parameters into your function. So we're going to handle that. What you would do is go public static. This is going to return an integer, and we'll create the new improved getSum2. And it is going to receive integers. However, it's going to receive an unknown number of integers, and it will still be able to handle it. What it's basically doing is receiving an array. We can now go int sum is equal to 0, and then create our for loop here, which is going to cycle through that array that we created, and it's going to say sum plus equal to whatever the value of x is. After it cycles through that entire array, it is then going to return sum. And pretty cool stuff. Now what we'll be able to do is go and send in any number of variables, and it will just work. So let's just have this be sum, and we will say get sum2, and we'll say whatever we want to do. So that's a nice way to be able to handle any number of variables. Pretty cool stuff. Now let's say you wanted to return multiple different values. How would you do that? Well, let's go and let's create it. Once again, public and static. And I'm going to do get next to, which is going to receive a value and then return the next two values that come after it. So it's going to receive an integer, and then it is going to create an integer array, and that's going to store two values, int and 2. And then what we can do is say values in the first index is going to be equal to whatever the value was that was passed in. And then we can say, once again, values and the second index, it's going to be equal to x plus 2. And then to return a array is no big deal. Just go like that. And there you go. All right, so we have that all set up. Whoops, make sure you come in here though and say that we want to be returning a integer array. And also, just so you know, you don't need public here, you can get rid of it, and everything will still work out perfectly fine. And then once again, down inside of our main function, I'm going to create an integer array. And let's just call this mult va is equal to, and then I can say get next to, and then pass in a value of 5, for example. And then I can go in and output that. So we can just go int x, because those are integers inside of the array that we're working with, and multiple values. And then let's go and output each one of those different values that are in there. And that is how we're able to return multiple values from a method. Another thing we can do is we can actually receive multiple values of different types. And how you do that is you can create a list using object, and every single thing inside of Java comes from this object and object class, whatever you want to call it. So we can work with it. So we can say something like get random list, and we can get a whole bunch of different things, and I'll create that in a second. And then we can come in and output the random list. Whoops, just by doing this, get rid of that guy. And there it is. And now we will create random list, or get random list. So again, get random list. And then we put the return type for it, which is list, and it has objects inside of it. And we can go get random, and don't forget to put in the return type. Close that off, and then within the curly brackets, I'm just going to go define a whole bunch of things. So string name is equal to Derek, and there we go. And then I can go arrays as list and put name and age inside of it and return those values. And if we come in and we execute it, make sure you spell this right, random list. Now I got it, and get rid of the OM on there. All right, so everything's fine now. And you can see that it returned that list of random different data typed items. Now I'm going to do something neat. We are going to go and create a recursive function that is going to call itself. So let's go and calculate factorials. So this is going to return an int, and let's just call it factorial, and what we want to get the factorial of. Now, whenever you're creating a function that actually calls itself, you need to, somewhere inside of it, have a condition where we will no longer call the function, and that is this guy right here. So we're going to say if num is ever equal to 1, in that situation, we are going to return a value of 1. All right, so that handled that condition. else what we're going to do is we're going to call the function over and over again. So we'll go result is going to be equal to num times and factorial num minus 1. And you'll understand this at the end, so don't worry about it if this is a little bit confusing. If you never heard of a factorial before, don't worry about it. I'll completely explain it in a second. All right, so that's all we need to calculate a factorial. Now what we can do is down inside of main, type in something like fact4 is equal to, and then call our function, so factorial and 4, and output that onto the screen. And if we run it, you're going to see we get a value of 24. And the way that works is I'm going to walk you through the whole process. Whenever we first enter into our function, we are going to provide it a value of 4, which is right here. Let's get rid of that. So we provide a value of 4, which comes inside of here. Is the number equal to 1? Of course not. We come down here, we go and have 4 times factorial, 4 minus 1, which gives us a value of 3. So we call the factorial function again with 3, which is this guy right here. We take the value down to 2, and then we have this. We jump down here. 2 times factorial 1. In this situation, it has a value of 1. It returns a value of 1, which gives this a value of 2, which jumps up here, which gives a value of 6. That 6 jumps up here and gives us our final result. So that's how recursive functions work, and that is how we would calculate factorials. And I'm going to do a lot more with really funky functions here later on, closures and such, but I wanted to give one more demonstration in which we pass an array into a method. So let's go nums is equal to 1, 2, and 3. Close that off. And then we're going to have a function. Let's copy this again, which is going to print out a sum. So sum is equal to, and we'll call it get sum3 and numbers. And then let's create get sum3. And how you define that you are getting an array is, this is going to return an int, is you go get sum3, for example, and you go int and put the brackets inside of there and numbers. Sometimes it makes sense to put the length inside of there as well. And then we can go int sum is equal to 0, and then we can cycle through this guy, integers of course, and this will be nums, and then we can go and have sum equal to each of those individual values of x, and then return the sum. And if we run it, you can see that we got the value of 6 there. So there you go. That's a ton of information, at least to start off. More on methods in a little bit, but now I want to talk about enumerated types. All right, so sometimes it makes sense to have custom types that have a limited number of options. So let's say, and you have to put them outside of the main function when you define them. So I'm going to go and I'm going to create a public enumerated type, and I'm going to call it day. And just to keep this brief, I'm just going to put a couple days inside of here. So I'm going to go Monday, Tuesday, and Wednesday. All right, so there are our different days. Now down inside of main, I can actually define my day, my custom data type, and I can go do something like favorite day is equal to day and Monday, and then let's go and output that favorite day and is, and then just go favorite day, and you can see that it's automatically going to work is Monday. All right, so just a very, very, very brief explanation of enumerated types, and now I want to talk about exception handling. Now, exception handling is going to be used to catch errors that could crash your program. So you're basically just creating them to protect your code. And what you do whenever you want to try to block one of those errors is you're going to surround problematic code with a try block, which is what that is. And inside of it, we could go and do something like int and bad int is equal to, and do a division by 0. And then if you do have that, you are going to want to catch that potential problem. And how you do that is with catch. And the thing we want to block here is the arithmetic exception, and we'll give it a value of EX, and we're going to use that EX if we do have this problem to come in here and output a message. So we could do something like can't divide by 0 inside of here, Or we could go and get other messages. So we could do something like get an automatically generated message that's such as get message is going to provide for that specific exception or error that we had. And we can go and also print this out in string format, which you'll see what that looks like here in a second, and close that off. All right, so that's going to catch a very specific exception. If you would like to catch all exceptions, and this is normally not good to do, but people do it anyway, this will catch any exception and provide a error message. So we'll go ex get message again. And then you will also have the opportunity to clean up after any of this code has been executed. You could do things like close files or databases or other cleanup things inside of the finally block. And then you could just put something in here like clean up. You'll see later on when we talk about file IO how that would be used. All right, and if we go and run it, you can see can't divide by 0 comes on here, and then it prints out a longer message, and then cleanup also comes on here. But you could also throw custom error messages if you would like. And what we will do is actually just get rid of that guy right there and instead go throw new. You could check for some problematic thing there that there is no exception for, and you could go exception and bad stuff. And this is automatically going to work as well. And if we run it, you'll see bad stuff comes up there, and this guy right here actually caught that one. All right, so brief overview of exception handling. And now, since Java is an object-oriented programming language, let's do some cool object-oriented programming examples. All right, so now what I want to do is talk about object-oriented programming. So what we're going to do is we're going to come over here and we're going to create warriors that are going to fight to the death. So first thing I want to do is create a class. And I'm going to not have a main function inside of it. And the name of my class is going to be warrior because that is what I'm trying to model. So I'm going to come down, click on finish. And here we have our bare bones warrior class. Now with object-oriented programming, it's very simple. What we are trying to do is every single real world object has attributes such as height and weight and capabilities such as having the ability to eat and run, for example. In object-oriented programming, we store attributes in fields and we model capabilities using methods. So we're just going to come in here. We're going to list some attributes a real world warrior would have. So we're first going to come in and mark this as protected. And what this means is it is code, or it is a field that is only going to be accessible inside of our class that we're creating, and also subclasses will be able to have it. If we mark this as private, subclasses would not have access to this thing, and that thing is going to be a name. We are going to say the default name for warriors is just simply warrior. Then we're going to say other things are going to be public, and such as our health. Our health is going to be very important for a warrior, so we are going to save it. Public means that this information will be available anywhere. So also, we're going to have an attack amount that our warrior can do. And also we are going to have a block amount that our warrior will be able to do. All right, so there we go. We have our attributes for our warrior. Now what we need to do is to initialize or set up a warrior whenever it is created. You do that with a thing called a constructor, and a constructor has the same name as your class. And a constructor can be so simple as just that. It basically, whenever a new warrior object is called, this warrior constructor function will be called. Now we could also come in and set attributes, which are a little bit more useful. So whenever a warrior is created, we can then say that we want to accept a name and give a data type, that we want to accept health and have that be inside of there. We can also say that we want to receive a attack maximum amount that the warrior can attack with, and also a maximum block amount. So I have this be block max. And there we are, and now we have that set. Now, if we want to refer to these attributes for a warrior, and we do not have a warrior object created, how do we do that? We have no way of referencing it. Well, we have something called this. That is just a way of referencing a object that we do not have a name for. What we're going to do is we're going to create setters and getters for for this name guy here. So I am just going to create this first and set the name. Well, why don't I create the getters and setters also? And the reason we do this is because we do not have direct access to name. So what we need to do is provide methods that are going to allow us to provide access. So we're going to say that we want to provide a string get name, and whenever this is called, it is going to just return the value of name. Now, the reason we use getters and setters is, let's say that we did not want to just return the name, that we would maybe want to return the name plus something else. Well, we could provide special output. For example, if we had something like weight, we might want to return kilograms or pounds or something added on to whatever the value of weight would be. And also, let's say that we would want to come in here and provide a way to set the name like we did up there. We can do so. And the reason we do this is, let's say we don't want the name to contain numbers. Well, if we could go and check, as you're going to see with regular expressions later on in the tutorial, we could check to see if it actually, the name contained a number, and we could say, no, we will not accept that name, and then not set it. Okay, so that's why we have getters and setters and things like that. All right, so now what we can do is we can go and set all the other attributes, such as health, which is going to be to whatever the health they sent in. And we can do the same thing for attack maximum amount, which is going to be whatever the attack max was that they sent, and also made that an uppercase K. All right, fix that. And then we could also have a block max, which is going to be whatever they sent in for that. Okay, so now our warriors have a way of being initialized. Now what we needed to do is to model the capabilities of a warrior. Now a warrior is going to be able to attack as well as block. So we are going to name it that way. And it's going to return an int, which is going to represent the attack amount. And inside of here, I'll just use a random number generator to provide just a random attack amount. And how we do that, I covered randoms before, so I'm going to say that I want to return 1 plus, and I only want to work with integers in here just because it makes it simple. Call math random, and then we will multiply that times the attack maximum amount minus 1. And if you want to know the details of how the random function works, you can just click inside the table of contents for this tutorial and jump directly there and see all the details. All right, so there we go. So we have that, and we're going to do the same thing for our ability to block. So we just want to keep this whole entire thing as simple as humanly possible so that it's completely understandable. And as you're going to see, I'm going to break up a whole bunch of this whole entire thing into multiple different files. So it'll be very, very easy to work with. And then we can come in here and do this, and then we change this to block max instead, and everything else is exactly the same. So that's all we have. We have a warrior who has a name, a health, attack amount, block amounts. We initialize it, and it has the ability to attack and block. And that's it. That's all we need to do for now. So now what we want to do is add more capabilities so that the warriors can actually battle. And again, we are simulating a real-world scenario, and the scenario we're simulating is a battle. So we will come over here and we will create a new class. Again, it's not going to have a main function, and it is going to be called battle because that's what we are simulating. And click on finish, and now we have that. So inside of our battle class, this is basically a utility class, and so in that situation it makes sense that all of the methods inside of it should be static. And like I said previously, static methods and fields should be used whenever it doesn't make sense for a real-world object to be able to perform some things, or when values should be shared by multiple objects, or in this situation where we have basically a utility class that's going to simulate a battle between multiple warriors. So what do we want to do? We want to have a situation in which we start our fight, and it is not going to return anything. So we will say start fight, and it is going to be passed a warrior, and which is going to be warrior 1, and it's also going to receive another warrior that we are going to refer to as warrior 2. We are going to use a sleep function, which is reserved for threads and such. So I'm also going to come in here and add in an exception, but I'll just do that in a second. So basically what I want to do here is I want to loop, giving each character a chance to attack and then block. So I will simulate that by putting in true inside of here. And then I want to create a function that is going to provide the attack result. So we will go and go static. Again, breaking up everything into very, very small pieces of code that are very, very understandable. So get attack result. This again is going to receive a warrior, and I'm going to call this warrior A. This is going to represent the attacking warrior. And then I am also going to have another warrior passed inside of it. And this is going to be warrior B, and that's going to be representing a warrior that is blocking. First thing I want to do is get our warrior's attack as well as our blocks. So warrior attacking, attack amount is going to be equal to whatever warrior A is, and call the attack function in the warrior class that we created. Also, I'm going to have warrior B, the block amount, and I'm just going to refer back to that. And we can get that by going warrior B and calling the block function. So everything is very much based around trying to simulate reality. What I need to do then is subtract the block amount from the attack to find out the overall damage. So I'll go damage to warrior B is going to be equal to warrior A attack amount and minus the warrior B block amount. So pretty simple, straightforward stuff. I'm then going to check if the damage is going to be greater than 0 before I go and try to decrease it. So I'll say if damage to warrior B is greater than 0. Well, in that situation, I will go warrior B, who's, blocking. Health is going to be equal to warrior B health minus the damage to warrior B. And is that right? Let's go like this, and that's going to be there. Okay, so got that all set up. Else, if it isn't, well, then I'm just going to say damage to warrior B is equal to 0. All right, so simple stuff. So we got that all out of the way. What do we want to do now? Well, I want to print some information about what happened during the attack. And what I want to do here is use the Printf formatting function to provide the more nice looking output. So what I'm going to do is go system and out followed by printf, and I want to have a string here. So what I'm going to do is put %s, and whatever the string variable that we're going to have here is going to be placed directly where that %s is, and deals. And then I'm going to add on to this. Let's go to the next line. So let's say plus, and then I'm going to put a integer, and integers are represented with %d. I'll provide a list of all the different types of variables you can have here. I then want to put a new line inside of there. And then what I want to put right here in my output is going to be the warrior A's name, and I call the getName function that I created to get that. And then what I want to place here in our output is going to be warrior B's name. So I'm going to go warrior B and call getName on that as well. And then I need to put the damage amount, and the damage amount is going to be damage to warrior B, the warrior that is blocking. And there it is. And like I said, printf is going to be used for formatted output. Anywhere you want to place a string, you put a %s, integers %d, floats %f. If you want to say limit the output to 2 decimal places, you put 0.2 in between the % and the f, and then you have characters, scientific notation, dates, and booleans. All right, so you can play around with that to get more acquainted with printf. I'm going to go and use printf again, however. So let's come in here and get this. So after I print that out, now what I want to do is print out the health changes. So go like this, and I will go %s has %d. This is an integer health. And then let's say we want to put in 2 new lines just to separate our output code so it's easier to see, because there's going to be a whole bunch of things just flying all over the screen whenever we do this. So now what I need to do is get the blocking character's name or warrior's name, and then follow that up with the blocking character's health. So we got both of those things. And there we are. So we have the attack information and all that. Now what I want to do is throw a sleep period, which means I want to pause the output for 1500 milliseconds. And to do that, I just come in, and I'll do more on threads here in a minute so that you know what a thread is. Don't worry about it. There's something I don't cover. And this just requires that I come in here and add in a ability to handle an exception. So I will say add throws declaration, and I can just do that to the method itself. And you can see that it went right there. And then we can come down here and continue adding in our additional code. Now what I want to do is I want to check if the health has fallen below 0 or not, because remember, start fight is going to be calling this function, and it needs to know when the while loop needs to terminate. So I will come down here and figure that out. So I will say if the blocking warrior's health is less than or equal to 0, then I want to end this whole entire thing. So I'll say system, and well, I have that saved, don't I? Yes. All right, so I will come in and go that has died, and the other warrior is, and we will go and add that in, victorious. So like this, and I put a space in there, right, is victorious. So, and then we can throw in a new line, and then we can go and add in this additional information by just going warrior block is, and get the name, because we know that warrior has died. We have to put the % in there because we have to call the getter on that. And then we will go and get the attacking warrior and output their name, showing that we were able to have a victor in our little combat here. Then in that situation, what I'm going to do is I'm just going to say return game over, and I can show you how to do logic in regards to this. And otherwise else, I'm going to say return, and I could actually put anything in this, but I'm just going to say fight again, and there it is. All right, so that's how the whole entire handling of attacks works. And now what I just need to do is iterate and have the warriors fight against each other. And how are we going to do that? Well, basically, I'm just going to say if get attack result, this guy right here, I'm going to call it multiple times. So get attack result, and I'm going to pass in warrior 1 and warrior 2 into this. And then I'm going to check to see if it is equal to or equals to game over, meaning that they fought to the death and everything's done. And then in that situation, I'm just going to output some information here. Whoops. And that information is just going to be game over. I could put in, you know, the game over that actually came passing in there, but whatever, that's fine. And then now that I got that, I can then say break to jump out of my loop. And this is also giving me an error because of the thread sleep down inside of here. So I can just come in here like this and then say add throws declaration, and there that goes, and that's going to protect that as well. All right, so I have to give both warriors an opportunity to kill each other. So I'm just going to copy this, and then I'll change this into a 2 and this into a 1. So both warriors now will continually attack each other until they die. All right, so I got the battle all set up. So now what I want to do is have a completely different class set up that is going to run all of this. So once again, come over into source and right click and new class. And I'm just going to call this warrior game. And in this situation, I'm going to want a main function. So I'm going to say warrior game, and yes, I want main, and everything else here is fine. And let's click on finish. All right, so we got this, and then everything is going to be taking place inside of our main function. So what do I want to do? Well, I want to create a warrior. So just go warrior, and let's say it's Thor. And to create this warrior, I just go warrior, and then I pass in the name, and then I just have to decide what I want the health and so forth to be. Let's say I just make it 800, and then the attack amount, Thor's pretty strong, 130, and the block amount's going to be 40. And I'm going to do the same thing for Loki, and then have them attack each other. And then I'm going to do all kinds of other things where I give Loki more abilities and all this other stuff. So I'm going to say Loki in there, and change this to Loki. And let's say that Loki's attack amount is less than Thor's, And there we are. And then how much does it take to come in here and actually have them fight each other? Well, I can just go battle, start, fight, and pass in Thor and Loki, or whoever I would want to pass into this. And it's going to just automatically work. And it also wants me to handle that exception. You normally wouldn't do this stuff with threads, but I'm doing it just so that I can make it look better on the screen. So add throws declaration, and that's okay. And we'll run it, and there we are. And you can see our output as Thor attacks Loki, and then Loki attacks Thor, and on and on and on. And this will continue until probably more than likely Thor kills Loki. So what we're going to need to do now is go in here and actually give Loki more abilities so he has a better chance of defeating Thor. And there you can see is the final output. Loki has died and Thor is victorious. So Loki is kind of a sneaky little guy. So why don't we go in and let's give him more capability. And how we're going to do that is by creating a subclass that is called Dodge Warrior. So we're going to come over here and we're going to create Dodge Warrior. So just this, right click and class. And this is going to be a Dodge Warrior, which is going to give Loki the ability to dodge. So we'll just go Dodge Warrior and no main again. And let's click on finish. And let's add some capabilities. First thing we want to do is we would like to get all the attributes and capability in Warrior. So we can do that just by going extends Warrior. And that's all we need to do. And now all of a sudden, everything that's in Warrior is also in Dodge Warrior. So what are we going to need to add in regards to attributes? Well, I am going to say that I want to figure out the chance that Loki is going to be able to dodge an attack from Thor. And I'm going to call that dodge %. And I'm also going to want to randomize that. So let's go and go rand is equal to new random. All right, so we have that set. And let's just go in here and get that library, import random, and there it is. So now what do we need to do? Well, we need to initialize our Dodge Warrior. So we'll just go public Dodge Warrior, and this is the constructor. And it also is going to receive a string for the name. It's going to get health just like before. It's going to get a attack amount or attack max. It's going to receive a block max. And it is also going to get the added capability of how likely it is that Loki or our Dodge Warrior is going to be able to dodge. Now, it would be great if we could just have our Warrior class constructor handle all this for us like it does there, and we can. So and how we do that is to call the Warrior constructor. We just say super because it's the super class. And we pass in all the things that it can initialize for us, and then we handle the things that it can initialize. So we'll say block max, and there we go, and the Warrior constructor will handle that. And then we just need to handle the things that are not in Warrior inside of here. So dodge % is equal to dodge %, and there we are. And now what we'd like to do is go and change the things in Warrior that we want to change. And the only thing we want to change is the block. So this is going to overwrite what is inside of Warrior, the block ability. There's block. So we're overwriting that in Dodge Warrior and adding additional capabilities. So we're going to say double chance is going to be equal to random and next double because we want to get a double. And then we will say if our chance is less than or equal to dodge %. Well, in that situation, we are going to print out on our screen, and we're going to use printf again. And we will, whoops, this, and we're going to say that we were able to dodged the attack. Throw in some new lines inside of there. And then after that, I can go and put in the name for my warrior. So go and call get name again, which of course is going to be there. And then this is going to return a block amount that is just extremely high just to make sure that no damage is done to our warrior that just dodged. So return 10,000. And otherwise, I'm going to say else, and I'm going to return exactly what it was in block before. So return this guy right here. So let's just copy that and paste that inside of there. So there we are. We got that all set up, and now we have a warrior that is able to randomly dodge. So how is this going to impact our warrior game? Let's jump back over there. So how this is going to impact it is we have Loki right here. All we need to do to add this additional dodge ability capability is change it from a warrior into a dodge warrior. We can still keep this as the warrior name and treat it as a warrior, which is super awesome. And the only thing we have to do here is add in the chance that Loki can dodge. So we're going to say that Loki has a 25% chance of dodging. Let's see if we gave Loki enough abilities to be able to survive an attack with Thor. And here we go. And you can see Loki dodged the attack, so there it is being used and is being quite useful. Well, as you can see, even though we gave Loki the ability to dodge, he still was killed by Thor. So what can we do if we want to go and give an object a capability that is not already inside of the warrior class, for example? Well, one thing you do is use an interface. Now, basically, interfaces are empty classes, and they define the methods you must use, but none of the code. And classes can only inherit one class, as we've seen so far when we subclassed warrior into creating the dodge warrior, but they can inherit numerous interfaces. And what we're going to do is we'll use an interface to define whether a warrior can or can't teleport. And we will add this capability without making many changes to the classes that we're trying to affect. And how we would do this is creating an interface called teleports. So we'll come in and go to source and new, and we will create an interface this time. And we'll come in here, and the interface name is going to be teleports. So we'll give Loki the ability to teleport away to save himself. All right, so there is our interface. And all we're going to do is we're going to say that it is going to receive, or it is going to return a string, and teleport is going to be this guy. After we do that, directly, because the interface basically doesn't do anything, I'm going to throw two classes inside of here, even though I could put them in separate files. And I'm going to say one of them is called can teleport, and how we go and implement the teleports interface is just by going implements teleports. And what this guy is going to do is we're going to override the teleport function. So we'll say public string teleport, and I'll show you a more traditional way of using interfaces. I'm using what's called composition here, which is kind of an advanced technique, but after you see the example, I think it'll make sense. So we'll say teleports away. If it has the ability to teleport is what it's going to return. And if it can't teleport, well, then we're going to do something different. So we'll just go can't teleport, implements teleports again. We'll put teleport inside of here, and we'll say return, and we'll say fails at teleporting. And this is going to allow us to add capabilities to those classes without really changing much, which is awesome. So what do we need to change here to get this to work? Well, inside of Warrior, I'm actually going to add a couple different things. But basically, if I want to add in the ability to teleport, what I'm going to do here is use what is called an instance variable that is a subclass of the teleports interface. And what this is going to allow me to do is at runtime, subclasses are going to be able to define whether they can teleport or not. So all I need to do, code-wise, is go public teleports. I don't need to extend this or do anything with the interface. And I'm going to say teleport type, which is going to be whether they have the ability to teleport or not. And that's all I needed to add there. And then at the bottom of this, I'm going to add in our different capability. So, which is going to be handling the teleporting ability and also allowing them to dynamically change the teleporting capability. And very little code is being used here, so all I need to do is go string teleport, and then I can go return teleport type and call the teleporting function inside of there. And then if I want to dynamically allow them to change it, I can say public void set teleport ability and teleports new teleport. And this is all composition, like I said previously. And then I'll show you a more, easy to understand way of using interfaces. And new teleport type. And that will allow them to change that. And this should be teleports and new teleport type. Okay, so we got that all set up. And that's all we needed to do to change that, to add that capability inside of there. What do we need to do inside of our other ones? Well, we could go into our dodge warrior as well. And right after our dodge %, we could add in teleport type is equal to new can teleport. And we'll say that it, by default, the dodge warriors are going to all be able to teleport unless we decide to change that. And that's all we needed to do. Add that one line of code and everything works. So are we going to be able to change or need to change anything else? Well, in Warrior Game, we're going to be able to come in here, and I'm not going to do it in the middle of the battle. Let's just keep this simple. Let's say that we want to test if Loki is going to be able to teleport away. Well, we can just go Println. And then we can do something like Loki, and then go and call to see if Loki is going to teleport away to safety. Teleport that. And then let's also come in and go and take away Loki's teleporting ability by going teleport ability. And then to change it, to take his ability away, we just pass in can't teleport, the can't teleport class. And there we are. And it's automatically going to take away his ability. And then we can go and print this out. All right, just to prove that that all works. And you can see Loki still died. And for your homework, what would be an awesome thing to do is to go in and use the teleporting ability inside of the Dodge Warrior class and do like a percentage chance that Loki can or can't teleport successfully if his health gets below a certain amount. All right, so good homework. And you can see that Loki teleports away, and then we changed his ability to teleport, and then he failed. Now, if you wanted to see, and this can be additional homework, a more traditional type of interface, here is a pizza interface. And you can see how we were able to implement pizza and then come in and add in the description as well as the cost. So that would be a more traditional interface in the way that they are used. You can go and make that on your own and test that out for homework. And then you also have things called abstract classes, and crashables here being used as an example. Basically the way that they work, they're not that different from interfaces. And they are basically going to be used whenever you don't require all methods to be implemented. And you would also like to provide for the option for methods to actually have code. As you can see right here, uCrashed actually has code that it has inside of it. So if you want to have some of your methods go and actually have code in them, use an abstract class. If you want none of your methods to do anything, then use an interface. All right, so there is a rundown of interfaces, abstract classes, numerous different things in regards to object-oriented programming. And now what I want to talk about is streams. Okay, so now what we're going to do is talk about streams. I'm going to create another class because everything's getting kind of busy here. So let's just go class, and then let's go and call it Java Tut2. And let's get a main function inside of here and click on finish, and there we go. All right, so basically streams are going to allow you to group groups of objects, and so you can perform aggregate operations on them. And I'll show you exactly what I mean by that. So let's first off come in here and let's create a list using a stream. So this is going to be integers, and I'm just going to call it 1 to 10 and equal to. And then I'm going to use the int stream and range closed, which is going to give me 0 through 10. And it's ranged close. I do that all the time. Then I just put in my 1 and my 10. Then after that, I'm going to type in boxed. And after I get all this done, I'll explain what all these things do. And then collect and collectors to list. So that's a lot of stuff going on there, but I'll go through the entire thing and explain it step by step. Okay, so first I'm going to come over here to the list and import the Java util. See if I zoom in, you can see it better. Java util module we have here, and there it is. Now basically int streams are going to be used with ints, and I have to also import that library. So let's go in, do it. And it's right here in Java util stream. So if I want to create an integer stream, I'm going to use int stream. Range closed is going to generate a list from the starting point 1 and through the ending point, which is going to be 10. Boxed is going to return a list that's boxed to an integer. Collect is going to process the list elements into a container, and that container is going to be a list container. And I can come in here, and that is range closed, and then I need to get my collectors class, and as I do this, you can see them showing up. All right, so a lot of imports. Now what I'm going to do is use map, and it's going to perform an operation on each value that we have. So I'm going to go, and I'm just going to copy this guy, and you'll see how cool this is. I'm going to call this squares, and that's going to be equal to 1 to 10. and stream. And then what I can do is run map. And what map does is it's going to take each one of those values inside of the list that I provide for it. And in this situation, I'm going to multiply them towards each other and then save them into a list again. And then collect. And I need to collectors, and once again, turn them back into a list. So there we are. And then close that off. Now I can use my enhanced for loop to output this new list that we have. And I can go and get X. And I'm working with a different function here. So what I'm going to do is come up here and I'm going to go down to run configurations. And I'm specifically going to get Java Tut2 and then come down here and click on run. And you can see if I run it that it goes and multiplies all those individual values times themselves and outputs that. Okay, so we can go and perform the same exact calculation on each item in a list. Now what I'm going to do is show you a filter, which is actually going to eliminate values based off of a condition. Let's come in and let's get this guy and let's just copy the whole thing. Paste that there. And I'm going to rename this guy evens. So what we're going to do is just keep our even values. Then after stream, I'm going to type in filter X, which is going to represent each item in our list. And then our condition is going to say if X modulus 2 is equal to 0, well, then I know that it is a even value. So I want to put it into my list. So collectors, and then once again to list. And a semicolon. Now what we can do is go and cycle and print that out once again, except this is evens, of course. And now you can see we just kept the even values. So that's the difference between map and filter. Now let's say that we would want to go and limit our stream. So lint stream, and I'm going to call this limit to 5 is going to be equal to int stream. I'm going to generate a bigger one. You can also use range. And I'm going to say 1 through 10. However, I want to limit to just the first value. You can use a limit with any of these other little guys if you just want to limit the amount of output that you get. And we can also go and get this int stream we have and instead go for each and list what we want to use for output, which in this situation would be Println. And there you can see we just got 5 values, even though 10 were generated. We can also use reduce to multiply all the values in a list or perform an operation over and over again on each of these guys. So in stream and range, and let's go 1 to 5, and then call reduce on it. And we're going to start off with value of 1. And then we're going to take each value thereafter and multiply those values times each other. And you just go X and Y. So it's taking out 2 values at a time and performing operations on both of them instead of, the other way we were doing it. And then we can come in here and output that. And you can see whenever we go and multiply them all times each other. Very, very powerful tool. You'd also be able to go and get an int stream and convert it into a double stream. So int stream. And let's go and generate 1 through 5 and then use map to double. And you just take one from one list and put it into the other list. Another thing that's very useful is we can generate different statistics. So I'm going to go create int summary statistics. And I'm going to call this istats is equal to int stream and generate a range 1 through 10. And then summary statistics. And you'll see what we'll be able to use this for. We can come in and get a average by going istats followed by get average. We're going to be able to sum them. Just putting get sum inside of there, get minimum, and also get maximum. And there you can see are our answers. All right, so a very quick run through of how we can use streams and map and filter and reduce. I'm going to do a little bit more with those as the tutorial continues, but now I want to talk about regular expressions. Now, Lambda expressions are basically functions that can be passed as if they are objects. So what I want to do is I want to create a list here. This is an array list, just as I created them whenever I was talking about streams and such. And this is basically going to be an array list with values 1, 2, 3, 4, and 5. So let's say I would like to multiply each of those values by 2. Well, what I'm going to do is I'm going to go 1, 2, 5, and I can go and call for each, and I can go and output onto the screen those values multiplied times 2, for example. Just grab x and multiply it times 2 and run it, and you can see that that's exactly what I was able to do. Now these are going to get more complicated. Let's say that I would like to cycle through this list and only output even values. Can do that as well. Again, going to use basically the same format, except here what I'm going to do is put in a condition, and you can put curly brackets inside of here, and that condition is going to be the modulus of 2. If that is equal to 0, in that situation, I want to print it out. Otherwise, I do not want to print it out. And you can put this directly inside of here, inside of curly brackets, and close that off. Neat stuff. And there you can see that I only printed out the even values. All right, so pretty understandable, especially if you saw the part with streams and maps and filters and so forth. So let's do something really cool. Let's generate Fibonacci numbers. So I'm going to create a list, an integer list, and I am going to call it fib equal to new and linked list. And this guy's going to perform magic. All right, so to generate Fibonacci numbers, I am going to create a stream. I am going to iterate over it, new int array, and I'll explain exactly what I'm doing here in a second. All right, so I'm going to limit this. Just give me 1 second, just to keep everything straight. Okay, so exactly what is going on here is that iterate is going to create what is called an infinite stream, starting with 0 through 1, as we define right here. Then what it's going to do is it's going to generate the next value that's going to go into this by adding the previous 2, which is how we did right here. So it's going to start off with 0 through 1 and then proceed onwards and onwards. And this guy can literally be infinite. What we're doing here is saying we want to limit our results to just 10. Map is going to store the results into our, what will eventually be our list. And then collect is going to process the list elements into a container. And then we're going to use for each to output all of them. Okay. And you can see here, if I run it, that it goes and generates those 10 values. And I can go and increase this like that. And it will go and get bigger and bigger and bigger, basically until it reaches the point where it is bigger than the actual data type that we are working with. Okay, so pretty cool stuff and multiple examples with Lambda expressions. And now I want to talk about file I/O. Now what we're going to do first is I'm going to show you how to work with files and directories and so forth. And I'm going to use a file object, which is a file or a directory. And to create one, you just say file and new file and define whatever you want it to be called. I'm going to call this file1log. And what we're going to do first is try to create a file on our hard drive, and there could be potential errors, so we're going to surround it with a try block. And I'm going to say if f1 create new file, then going to output that the file was created. And now that it has been created, we can go and do different things. So we could come in and do something like rename it. So rename to, and just go new file, and let's call it F1 backup log. And then after that, we can come in and delete the file. So let's delete the old one anyway. So that's how we can create and rename and delete files. Else, well, we know we have some sort of problem with the file not being created, so let's output that, file not created. And of course, let's go and put an equal sign inside of there. And the error that we're going to catch here is going to be an IO exception. Have that be E. And then we can print out any exception that would occur. Now what we want to do is create a file object and tie it to a directory to show you what we can do with directories. So file again, new file, and I'm just going to use the directory that I'm currently in, that I'm currently programming in. And if you're on Windows, you have to switch the direction of that. And now what I'm going to do is go and check if this is a directory or not. And if it is a directory, let's say I'd like to get a list of all the files and stick them into an array, all stored as files that I can perform different operations on. And to do that, you just go list files, and then we can go and output each of the file names. Pass that inside of there, and to get the name, you just go get name. Now a stream is going to be a sequence of characters, and character streams are strings basically, and binary streams are bytes of data from primitive types. So what I want to do now is create a file for writing text to. So to do that, again, just go File, F2, New File, provide a name for it. So let's call this F2 and text. Oh, let's go and output this first. And you can see that it outputted all the different files and directories that I have inside of the directory. Okay, so now we can go and write in this. Now again, we're going to be working with files, so that means that we are potentially going to create an error. So what I'm going to use is the print writer to write text to a file. And I'm going to show you two different ways of doing this. So print writer is going to be equal to, and I can say new print writer. So I'm going to write to a file, and then I'm going to go in and read from a file. And if you're wondering what I'm using here, I am actually using the Java IO libraries. So inside of print writer, I will then have, let's go to the next line, new buffered writer. And basically what print writer does is it formats the data that you're going to be writing, while the buffered writer is going to save data until it is time to write, so that it writes it all at once instead of trying to write constantly while you're performing this action. And then we're going to go new file writer, which is actually going to write the characters. And then you put your file inside of there. And if you would put true inside of there, that would actually append information, but I don't want to do that in this situation. And by append, I mean like add to the end of the file versus overwriting what's already there. And now that I have the print writer set up, I can write text directly to it just by referencing it. And I go print writer and print line, and then the text that I want to show in there. So I'll say this is sample text, and then I can close my file. And then, of course, I'm going to open it again and read the text from it. And this is going to potentially throw the same error that we had before. So let's throw that in there, and that'll handle that. Now let's go and read information from a file. So again, I'm just going to use F2 again, is equal to new file and F2. You could give it a new name if you'd like. And then once again, I'm going to be trying to open this, so it's a potential problem. So let's go throw try blocks inside of there. And what I want to do here is read the data one line at a time. So you don't need to stack these like this. Some people like it, some people don't. I'm going to show you the other way of doing it. So this is a buffered reader, and it reads data one line at a time. So let's just call this BR is equal to new buffered reader. And then inside of here, we can say new file reader and the specific file that we're going to be reading from. Once again, I'm going to go and get the Java IO buffered reader library. That's where I'm pulling information from, or that's where the libraries I'm using. Then I can come in and read the line that I want. Let's just call this text is equal to buffered reader and read line. And then I can cycle through and stop whenever a null is reached, and null is going to be the end of our file. So not equal to null. As long as there's stuff to read, we will read it. I can go and output each of the lines. I only have one line though. And go and read the next line if there is a next line. But we know there's not going to be. For homework, you can go in there and throw in more text if you'd like. And then after we're done with that, of course, we're going to want to close our file. And again, it's going to throw the same exception if we have a problem. So there we are, and you're going to see that we were able to both write as well as read text from a file. Okay, so that's how to read and write text to a file. Now let's talk about how to write binary data. All right, so we'll create another file, and let's call this F3. None of that changes in regards to text versus binary data that you're going to be writing. All right, so we have our file created, and we're working with files. And another thing we need is file output stream. Let's call this FOS. And this is just going to connect to the file to write our raw bytes of information. Writing information, so that's going to require a try block. And let's just initialize this object and pass in the file that we're going to be working with. Again, if you would put comma and true after this, it would append versus overwriting the file. Buffered output stream is going to allow us to write in bulk instead of trying to write individual parts individually. And you're going to pass the file output stream inside of there. Now, if you want to be able to write primitives to a stream, you're going to need the data output stream. And you need to import this library again. You're going to use Java IO once again. And to this, you pass in the buffered output stream. And now we create the data we want to write to it. So we can go and write strings to it, and we can write anything we want basically. Say an integer and a double. So a whole bunch of different things. And how you write specifically is, let's say you want to write a string. You could do that. You're going to use different functions to write different data types. So if you want to write a string, you use write UTF. If you want to write an integer, you're going to use write int. And if you want to write a double, guess what? You write double, and there it is. And then, of course, you want to close your file after you are done writing information to it. And this potentially is going to throw the same error that we saw previously. Now, if you want to read that information from that stream that you just created, you can go and go new file and get the same guy again, except this time we're going to use a data input stream to read. And so we use file input stream. Again, we're going to use a try block, and let's go and get this catch right here so that everything works. Paste that inside of there. Now we'll go file input stream is going to be equal to, and initialize this file input stream, and pass in the file we want to work with. We want to add buffering once again, buffered input stream. And I'm going to just come in here and just change this to a star, just to get rid of that hassle. Should have did that earlier. Do the same thing with this. Okay, everything still works good. And then you just pass the file input stream into that. And then there's multiple different methods you need to use to be able to access that primitive data that you wrote to your file. And the data input stream is going to provide you with those methods. And you pass in the buffered input stream for that. And then we can just go and output that information just like any other type of information using Println, data input stream. And then if you want to read a string, you just go read UTF, and you're going to do pretty much exactly like we wrote the information. So this is going to be read int. And then do another one, and this is going to be read double. Then of course you're going to want to close your file input stream, and close, and that should do it. And there you can see that we wrote as well as read that data from our file. All right, so there's a whole bunch of things in regards to working with files and directories and reading and writing multiple different types of data in Java. Now I want to talk about generics. All right, so generics basically allow you to use any type, any object type, and perform an operation on it. So let's go, and I'm going to create two completely different types. This is going to be a string array, and let's go and define that, and let's have it be 1 and 2, just to keep it simple. And I'm going to do the same exact operation on two different types of data. So we have a string array, and we're going to have an integer array. And we'll just go and define those values inside of there. And then we're going to actually do this inside of a method. And if you want to work with an unknown data type, we can just go public and static. And what you're going to do is define your type inside of angle bracelets using an uppercase letter. This is actually not going to return anything. It's just going to print this information out on the screen. Again, we don't know what we're getting. We just know we're getting some type of an array. And then we can use our enhanced for loop. Again, just put E in there. It'll work with anything. E basically represents any type of data. And then we can say that we want to output that data. And it's just that simple. Now what we can do is go print stuff and pass in our different files and know that they will work. Our different, completely different arrays. So there's that. And there is our integer array. And boom, they both work. Okay, so cool stuff. You could also come in here and accept an array list that could contain just about anything. So let's go public static void. You can do anything. I think I taught you enough Java at this point that you'll be able to print just about anything. So this is going to print any type of array list. And how you define that is by putting a question mark inside of there. And then once again, we can go copy this, and we can use object here to represent any type of object, and just change this to AL, and it'll cycle through and print out exactly what we have there. And you could also, while I'm here, might as well just go and create a generic class to show you how that would work. So come down here and go class my generic, and it'll work with any type as well. Again, T is going to have a random type that's going to be stored in value, and we could go public and void. We can set the value again by not defining the data type and know that it's going to work, and store that value inside of here. And then likewise we could provide that value back to the user. Again, whoops, it's going to provide it. So we can just throw T inside of there, and as long as the data type's the same, it will work, and return value. Okay, so there's another one. And now let's go and demonstrate that. So back up here, create an array list. Of course, this will work for anything. 1 is equal to new array list. And then let's go and generate one. So use arrays and as list and 1, 2, and 3, and 4. And then you can pass it inside of there and know that it will work. Let's print AL. And you can see it worked. Now what we're going to do is create a generic custom class. So my generic, and like I said, you can put any type in there you'd like. Just call this my GI equal to new my generic. Again, it's going to be an integer. Then I'll be able to go my GI and set our value to 10, and we can output that information just by referencing get value. So my GI and get value, and then we can copy this, completely change the data type, and it'll still work. Paste that there, change it into a string instead of an integer. Of course, change this into string. These have to match up. Set value, we can just change this to dog or whatever we'd like, and then this is going to be, let's make this my GS for string, and we don't even have to change get value. That'll still work. And if we do that, you're going to see we're able to work with both data types in our generic class. So there you go, rundown of how to work with generics, and I think I taught you enough that you can do pretty much anything else you'd like to do with them. Now I want to talk about threads. So basically, a thread is a block of code that is expected to execute while other blocks of code execute. And let's go and first let's create a function that's going to contain that block of code. What you're going to do is you're going to come down here and you're going to create a new class. I'm going to show you a couple different ways of working with threads. And we can go implements, runnable, and that's going to give you an error because it needs you to implement the run method inside of it. Add unimplemented methods. And then this is going to be the code. This is going to be the code that's going to execute. So what we want to do here is let's print out a couple different things. Like let's print the number of active threads. So just blocks of code running at the same time as other blocks of code. So active threads, just so you can see how many there are. And to get to the number of active threads, you just go thread and active count. Close that. And what else do we want to do? Well, whenever the thread is first started, let's say we want to output that, the thread has started. So start thread, and then thread, current thread, and get name, and we'll define a name here in a second. Then what we want to do is we want to actually pause execution for a certain period of time. You saw sleep previously, and let's put 3000 milliseconds inside of there. You have to surround that with a try block. And what we do is we catch the interrupted exception and print out any type of error that we would have there. And then after we are done sleeping, we want to print that our thread has ended. So we'll just come in here and just say end thread, and it's going to output the name as well. Okay, so that's all we need. We just need something inside of the run method that does something to treat this as a thread. Now what we can do up inside of main is go and create a thread. Call it T1 is equal to new and thread, and create a new my thread object. And then give it a name so that we'll have something to output, and we'll just call this thread 1. And then we're going to do the same thing for another thread. Call this T2 and change this to thread 2. And then let's create another one. What the heck? Let's go and create a third one, and thread 3, of course, and thread 3. And then we can go and run them. So we can go T1 and on each one of them, and you will see how they work together to get their jobs done. Go and run it. And you can see active thread listed as 4. And you might say, why is that? We only have 3 threads. Well, main is actually a thread as well. And you can see here that we go and we started thread 3, started thread 1, started thread 2, and then we went and closed them in the same order. And if we run it again, you're going to see that the threads may start and stop in different ways. Perfectly normal. There are ways to stop that as well. And one thing that we can do is let's have the third thread actually wait for the first to finish before we actually start running. How would we do that? Well, we got both of these guys running. We could then come in and go try, and we're going to have our interrupted exception inside of this as well. Paste that there. And then inside of our try block, we can join this to the first thread and then try to run our third thread. And you can see in this situation that the third thread does not start execution until after the first thread has actually ended. So another thing we can do, and we can do more. There's more ways of locking things up here so that the threads behave themselves. Let's say we would like to simulate a bank account that is only going to allow one customer at a time to go in and withdraw money. So let's create a customer class. Call it name, and let's go and just provide the customer's name just for tracking purposes mainly here. And this name is going to be whatever the name is you pass in. Okay, so we got that customer that's created. Now let's go and simulate a bank account by going bank accounts. And then inside of this, do some more complicated things. I'm also going to show you how singletons work. So you can only have one bank account at a time. So just to cover even more information inside of this tutorial. So we're going to have a balance, and let's say the balance is $100 or 100 whatevers. So static, and we're going to have a customer. All right, so what are we going to be able to do here? This is basically how you're going to set up a singleton so that there is only ever one bank account. What we're going to do is go public static bank account. It's going to return a bank account even though it is inside of a bank account. So what we're going to do is we're going to say get bank account is what's going to be called to create new bank account objects. And you're going to pass a customer inside of here. And we're going to say if account is equal to null, then we know that there is not currently a bank account. There has not been an account been initialized. And that's lowercase a. So in that circumstance, what we want to do is we want to go and create a new bank account. So this is the only way a bank account ever gets created is if one has never been created before. Then what we do is we say bank account customer and assign our customer, and then we return our account. And there we are. So that's how to make sure that you only ever have one bank account or one object created for each class. It's called a singleton. Hopefully, if you ever have any questions, just leave them in the comments and I will answer them. So now what we want to do is get our balance, because that's the whole purpose of this, is to make sure we don't overdraw accounts by having multiple customers go in and withdrawing large amounts at the same time. So that's going to return our balance. And then what this guy's going to do is actually withdraw money from the account. And if you want to protect it so that only one thread can ever execute this code at a time, you put synchronized inside of there. It's not going to return anything. And then you know that you will only ever have the ability for one customer to ever withdraw information at a time. So have this be withdrawal and the amount of money they want to take out of the account. Then we're going to go try, and we're going to say if the balance is greater than or equal to the balance that they want to withdraw. Well, in that situation, it's okay for us to output that information or withdraw that amount. So we will say customer name plus, and then we're going to go and get some information, requested a certain amount of money that we deemed is okay. And then we're going to put the thread to sleep. And this is how, let's say for a period of time that's, just in there to basically show that we are protecting our balance. And then we are going to subtract the balance from the account, and then we will output a new message. And that's going to be customer name plus tried, that's going to be received, the amount that they asked for. And then else, if they asked for more money than is actually in the account, well, we got a problem there. And let's catch this exception. Let's just use a junk exception that's going to catch everything. So we'll go catch exception E, and that'll catch every exception. And go and print an error message. Else, if they tried to take more money out than is available inside of it, we're going to print a message saying, that's not cool. We can't do that. And we'll just say tried to exceed balance. And then let's go and also output the current balance after all of this is done with. So do this, and we'll go current balance and $, and whatever the balance is. And then let's throw in another print line just to have separation in our code. And now what we'll do is put all of this together using runnables so that we can go and have our threads run this different code. I'm going to call this thread test, and this is going to extend thread and implement runnable. Okay, so what we'll need to do here is set up our constructor, so thread test, and we're going to receive a customer object, and then just assign that. So customer is equal to whatever the customer is. And I'm going to go and put a customer inside of here. So customer, there we go. All right, so there's our constructor. And then we are going to need to have the run function. So public void run, and then cycle through and get accounts and try to take money out and then sleep as we run through this. So I is equal to 0. While I is less than 4, just randomly trying to take money out of the account. We're going to go try. Let's go and just use our regular old catch-all for our exception. We're using this for sleep. That's why we're surrounding it with the catch block there. All right, so we got bank account, and let's go and create a bank account. But remember, there can only ever be one bank account. And to create it, you just need to create or pass in a customer object. Now what we're going to do is try to withdraw money from our account, and we're going to try to withdraw $10 each time. So eventually we're going to have problems because we only have $100 in it. And then we have thread sleep, and let's just have that be 1,000 just to slow down everything, and everything else there should be cool. All right, so got that saved. Now let's go and use it to test out our whole entire system and see if we can overdraw the account. Now let's go and create a couple different threads and have them all try to take money out. So thread test is equal to T1 is equal to new thread test. And remember, we have to pass a customer into it. That's the only requirement. So we'll have Sam go inside of there, and then let's create a couple more of those. And we have to start our threads, of course. So T1 and start. And then we'll create a couple threads and see if we were able to protect our account from having multiple, or from being overdrawn. So we'll change this to 3. We'll change this from Sam into Sue, and we'll change this into Sid. And that's all we need to do. Let's run it. And I had a little bit of an error, and that's because I didn't change this to 2. And change this to 3. Got that saved, and now let's test it. And you can see right here, Sid's trying to get money. He gets it. The balance goes down, and you can see how all of the customers are taking out $10 at a time. Eventually, we will run out of money, and you can see that they tried to exceed the balance, but our system protected it. Okay, so multiple different ways we can use threads, and now I want to talk about databases. Okay, so I'm going to be using MySQL for connecting to a database, and I'm going to be using the connector to provide for the easiest way for you to set this up to test everything. So what you're going to want to do is go to devmysql.com downloads connector J, and specifically what you're going to want to do is under select operating system, come down here where it says platform independent and download that. Then what you're going to want to do, also, you're going to need to install MySQL. I'm not going to go through that. I'm sure you'll have no problem doing it. But I'm specifically using MySQL 5.7, not the newest version, 5.8, or like Oracle likes to call it, MySQL 8. I'm doing that only because of security issues and so forth. Use 5.7, especially if you're a beginner with databases and Java and so forth. It'll save you a ton of time and you're not giving up on anything. So I'm using 5.7. Then what I have here on the screen is everything, and in the description underneath the video I have a link to all this. You can copy and paste. This, after you download MySQL, is how you set up root. Then this is how you change the password for root. This right here is going to create a database for our students that we will be using. I'm going to say that we're using the database named students. This is going to be how we are going to initialize everything. I'm not going to get into what all these commands mean. I have a MySQL tutorial. You can watch that, but you can just copy and paste all this in. This is how you insert information into each of the pieces in regards to different student names. This is how you create a new MySQL system administrator. This is going to be the password. This is how you grant privileges to give this new user the ability to use your new database you created. And then here you can also see the permissions you provided. Okay, so they're all on one page. You can pause or you can copy and paste what is in the description. Otherwise, now I'm going to jump over and show you how to access this database and make changes. Okay, so here we are. I trust you have a database set up exactly as I had on the previous screen. Now to access this database, you're going to use the connection like this, and you go and import this. But what you're going to want to do first is get the connector. So how you do that is you come over here to your project. I have mine called Java Tut, and you're going to right click on it, and then you're going to come down here to where it says build path if you are inside of Eclipse, and then you are going to configure your build path. So there we are. Then we can come in and go to class path. Make sure you have libraries selected right here. You're going to click on add external jars. This guy pops up, and this is the file that I told you to download. MySQL connector for Java, and there it is. And click on open, and there it is, and apply and close. You may need to restart Java, but everything should work fine. Now what we're going to do is with connection, come over here, and you're specifically going to want Java SQL, this guy right here, and click on that. And now we're ready to rock and roll and access our database. So what we're going to do here is inside of try, anytime you're accessing the file system, you're going to want to use a try block. What we're going to do is we're going to go class for name and com.mysql cj.jdbc.driver. Now what you want to do is provide the URL that you're going to assign to this. So this is going to be so that you can access the student database, and that is MySQL localhost and students to be specific. String, you're going to have the user defined, and that's going to be the SDB admin, as I showed you previously, to set up. We're also going to have another string, which is going to be whatever that administrator's password was, which I have set for turtledove. You're going to now go in and be able to issue queries to your database, just as if you were doing it in any other way. So to do that, you go get connection and you pass in the URL, the user, and the password. And this is going to be con is equal to driver manager, get connection. And this is going to want us to use Java SQL again. Let's just come in here and save ourselves some time and put a star here. And there we go. Now we're going to have everything we want. There we go. This next guy is going to send queries to the database for our results. Con and create statement. And then we need to actually create the query we are going to use for getting information. So I'm going to say that insert. I'm actually going to show you how to insert data into the database. Insert into student. And then we will go first name, comma, last name, street. These are the names of the different fields in our database, and student ID. So those are all the different things that we are going to reference in our database, or be entering information into it anyway. Then we say values, and then we put in whatever specific information we want. And this would work really well as a method, but whatever. And then inside here, we will go and inside of quotes, put Shelley for the first name, and those are single quotes. And then we're going to put Johnson, and then we will put 321 main, and then we'll put null inside of there because the student ID is automatically generated. And there we go. So this is a query that is going to insert a new student into our database. And how we execute our queries is just go S and execute, update, and pass in our query. All right, so we were able to enter new information. How do we get results? And between the two of these, you're basically going to be able to access and get anything you could ever want out of your database. Select first name, last name, and street. That's the information I want to get out of the database and from, and the database that we're working with. Or this is actually the table we're working with. So that's from student. Then we can use results set to cycle through our results. And how we do that is we execute our query once again. And of course we have to pass our query in. Then we need to go and get the specific information as we cycle through our results. So this is going to be different depending upon what type of data we're pulling out. So go and get a string out of here. Actually, all of these are going to be strings. Get string, and first name is the name of that data we're going to pull out. And then we're going to do that for all the other data, pieces of data in the database that we're pulling out of there. So also last name and also street. Okay, so we got all that out of there. Now what we can do is we can safely close our database, of course, outside of our while loop. And if you wonder what the other things are, you have get string. You're also going to get boolean, get date, get double, get int, and get long. I'm not going to type that out. All right, so we got our while loop. We cycled through everything. We got all our results. Now we need to close our connection to our database. And then we need to catch any issues that we have. And the potential issues are class not found, exception, and the other exception that we could have is going to be an SQL exception if there was something wrong with our query. And I think everything there looks like it's working really well. Let's run it and see if it works. Oops, got an error. What's the error? And it says on line 28 is where I have my problem. And I see where the error is. I forgot to put a comma right there. So let's save that, try it again. And it worked. And I accidentally hit Shelley Johnson multiple times. That's why there's multiple Shelley Johnsons. All right, so there you go, guys. That is about as much information on Java as I could possibly put into one video. Believe it or not, I was actually going to also cover Java FX, Java Web Start, Servlets, and server pages, but I thought this tutorial would be so long. But if you guys tell me you want to see that, I'll make a supplement to this video, and I will make it as quick as possible. So please leave your questions and comments below. Otherwise, till next time.